Hello everyone, welcome back to another SLHL video. Today we're going to be starting energy from fuels. So let's look at how do we define what a fuel is. Well, a fuel is a source of chemical energy, and this energy is released when our source is oxidized. And we have two main types of fuels, which would be our renewable and non-renewable sources. So let's start off with combustion. So combustion, let's get some space. Beautiful. So combustion is the name that we give to a reaction in which we have a hydrocarbon, usually it's a hydrocarbon fuel, which is oxidized in order to form water vapor and carbon dioxide. This equation is not balanced, but at least you will be able to get the idea of what the products of a reaction undergoing complete combustion looks like. So complete combustion, as we can see, is characterized by the oxygenation of a hydrocarbon fuel in which there is sufficient, if not excess, oxygen, resulting in these two products that we see on the right. In terms of your choice of fuel, so choice of fuel, you can choose your fuel depending on its specific energy, which is the energy released from a fuel over the mass of the fuel consumed. So you can see essentially how much energy you can get from a set amount of this fuel, seeing which has the most energy. So let's say specific energy, this is just not the right way to spell it, but this is just so that you guys can understand. So energy released from fuel over mass of fuel consumed. And let's look at incomplete combustion. So incomplete combustion, as you guys may be able to guess, is the opposite of complete combustion. So you do not have enough oxygen in order to form both water vapor and oxygen as your products. Carbon dioxide. Instead, we'll often end up having soot, so carbon monoxide. You can also still get carbon dioxide in these reactions because you can have a combustion reaction in which only part or only a fraction of the combustion that is occurring will be complete, even though the rest is not. And let's just kind of look into what each one of these products are. Carbon or soot is a pollutant, and these end up as atmospheric particulates, which do reverse greenhouse effects by reflecting shortwave radiation from the sun back into the universe and scattering it. But this is poisonous as it's very damaging to the heart and lungs. Carbon monoxide, often something that you hear about when people mention leaving the gas tap on or having a gas detector, more times than not, it's because they're telling you to look out for carbon monoxide, because this is a colorless, odorless gas which very effectively binds to hemoglobin. So these are the oxygen carrying proteins in your red blood cells, which means that your body will not be able to oxygenate itself, and it will also in the buildup of waste products in the body. Oftentimes when you are in the presence of carbon monoxide, if it is in excess, this will lead to grogginess, you'll end up falling asleep, and then you will die. So that is the danger of carbon monoxide. It irreversibly binds to red blood cells so that no cells in the body can be oxygenated, nor are they able to get rid of their waste products. Red blood cell binding. And then carbon dioxide. This one is very well known. This is a greenhouse gas, as this will accumulate in the atmosphere, and it has, or better yet, it is very hard to break the bonds in carbon dioxide, so it often lasts and stays in the atmosphere for a long time, unless used in photosynthesis by plants. And these are greenhouse gases, as the heat that reflects off of the earth will hit these particles and be kept in the atmosphere, serving as a blanket, keeping the planet a little bit too warm if it is in excess. And that is really all that we need to know for this introduction to energy from fuels. Thank you for watching, and I hope that this was helpful.